Okay, so next bit that we're going to do with the scalar product is using the scalar product to calculate the angle between two vectors. Right, so we take our first formula, so we've got the dot product of A and B, or the scalar product, is equal to the magnitude of A times the magnitude of B times the cos of the angle in between them. Okay, we don't need to remember this other formula, we just need to remember what to do, which is to divide. So to get the cos theta on their own, because it's being multiplied by those two, we get the magnitude, the dot product on the top, and then the magnitude of A times the magnitude of B on the bottom. Okay, so from there, we then can kind of substitute in the second formula for the dot product to get A1 B1 plus A2 B2 plus A3 B3 all over the magnitude of A times the magnitude of B. Okay, so all of this looks like it's a bit confusing to start with, but honestly, when you get into these questions, all of these things that we're doing, we know how to do. Right, so we're going to have a vector u, which is going to be equal to 3, 7, minus 1. And we're going to have a vector v, which is going to be equal to 2, 3, 5. Okay, and we're wanting to find the angle between these two vectors. So we know that cos of that angle is going to be equal to scalar product of those two divided the magnitude of A, magnitude of B. This time, obviously, because we've got u and v, it's the dot product or the scalar product of u and v, not u and b. They do sound similar, but they're not the same. Right, u and v over the magnitude of u times the magnitude of v. So over at the side, to kind of put these to work these out to put those into there, the scalar product is like u1 v1 plus u2 v2 plus u3 v3, just changing these for the different ones. So we get 3 times 2 plus 7 times 3 plus minus 1 times 5. Okay, so that's just taking our x components, multiplying them together, our y components, multiplying them together, and our z components and multiplying them together. Then we add those once we've got them, so we get 6 plus 7, 14, 21 plus minus 5. Okay, so that is 22. Right, so that is ready for us to plug it in. So we're going to get 22. Then on the bottom, we are finding our magnitudes. So the magnitude of u is equal to the square root of 3 squared plus 7 squared plus minus 1 squared. Okay, this is going to be a question that you would have a calculator for. So 3 squared plus 7 squared plus minus 1 squared. Okay, so we get the square root of 59. You can leave it as a third, that's not a problem. Magnitude of v is equal to the square root of 2 squared plus 3 squared plus 5 squared. Okay, so 2 squared plus 3 squared plus 5 squared is 38, so we get the square root of 38. Okay, so we get 22 over the square root of 59 times the square root of 38. So we've got all the bits we need. So therefore, theta is the inverse, to get the angle on its own, of 22 divided by square root of 59 times the square root of 38. Okay, for these, we are working in degrees. Okay, not radians, so we've got the inverse cos of 22 divided by the square root of 59 times the square root of 38, being careful to put into our calculators properly, and we get that the angle between those two is 62.3138 8, etc. Keeps going. So we round that to 62.31 degrees to 2 decimal places. Okay, I'm going to do one more example of these, don't worry, finding the angle. But if you're happy with that, you don't need to watch the rest of the video. If you'd like another example, I will do one. Okay, so let's have a go with another example of finding the angle between two vectors. So we're going to say that we have vector n, which is going to be equal to 2, 4, minus 3. I'm going to have vector O, which is going to be equal to minus 3, minus 1, plus 7. We don't need that plus in there, but because I started it. Right, so same as before. We know that the cos of the angle has got to be the dot product of A and B over the magnitude of A times the magnitude of B. Okay, this time we don't have A and B though, we've got N and O. So we've got N and O, magnitude of N and the magnitude of O. Okay, so don't want to hear any no jokes either. Right, so we've got the scalar product of N and O, or the dot product. You'll hear already that I use these quite interchangeably, and they just mean the same thing. So that's going to be 2 times minus 3 plus 4 times minus 1 plus minus 3 times 7. Okay, you don't have to write out all of this every time. It's not a problem. Okay, so we've got, you don't have to write out the N1O1 plus N2O2 plus N3O3 every time. So we get minus 6 plus 4 times minus 1 is minus 4 plus minus 3 times minus 7 is minus 21. Right, so we're going to end up with minus 31. Right, so we need the magnitude of n, which is going to be the square root of 2 squared plus 4 squared plus minus 3 squared. Okay, again, these you will probably have a calculator. I can't see you not having one. So 2 squared plus 4 squared plus minus 3 squared. So we get the square root of 29 for that one. And the magnitude of O is the square root of minus 3 squared plus minus 1 squared plus 7 squared. So when we get that, we get 59. Okay, so here we're going to have minus 31 on the top, and we are going to have the square root of 29 times the square root of 59 on the bottom. Okay, so this negative here, I've put this one in on purpose as an example of what's going on. With our vectors, the maximum that we can have is an angle of 180 degrees between two vectors. Otherwise, we're always looking at either the acute, the right angle, or the obtuse angle. We're never looking at the reflex. We're always going to be looking, so if we've got two vectors like this, the angle we're finding is that one in there, not the long way round. We're not doing the long way round, okay? So that means that for this one, because we've got a negative, it's got to be in the second quadrant because we're not looking past 180 degrees. Okay, so to find the angle, it's going to be 180 take away whatever we find there. So that is the cos to the minus 1 of all of this. We can do this all separately if we want, not a problem. Find the relative acute angle like we would when we get to trig equations. Okay, so we're doing 180 take away the inverse cos of negative 31 of just 31. Don't put the negative into your calculator, so it shouldn't be a negative in here. Should just be 31. because remember we don't put negatives into our calculators with those. So 31 divided by, and then we've got the square root of 29 times 59, and we get that it is 138.5418, and then it keeps going, so we round to get 138.54. Right, so that is our answer. So that means the angle between those two is that angle there. So it's an obtuse angle between these two vectors. Right, so just as a wee summary for what we've been doing here, finding the scalar, using the scalar product to find the angle between vectors. Okay, so we have to use both formulas, but again, remember you're given those, you don't have to remember them. We rearrange, and then we can solve to find the angle. Right, so hopefully you're starting to get the scalar product stuff. We've got 2 more things we need to be able to do the scalar product, and then that is us done with Unit 1. So if you've got any questions about this, leave a comment and I will get back to you. That's us.